used to solve equations that involve exponents. So one of the formulas we've seen before is compound interest. And if you remember, compound interest is problems that involve interest compounded a defined number of times a year. So if we look at the formula that will be given to you, A is the amount you want to achieve, P is your principal, the amount you start with or the amount you're going to invest, R is your interest rate, N is the number of time it's compounded, and T is years. And something you probably want to have on your notes if you don't remember, annually is how many times a year? 1. Semi-annually is 2 times a year. Quarterly is 4 times a year. And monthly is 12. Of course, we could have daily, which would be 365, but it's not as common. So the biggest thing you have to remember is that if you are compounding, let's say quarterly, that you are going to put a 4 here, and then you are going to take time, which is in years, and also multiply that by 4. So just remember that you will be putting in N 2 times. The other thing that we need to focus on is that your interest rate should be in decimal form, okay? So you don't want to forget that, for example, 6% interest is really 0.06, and if you can't remember how to change a interest to a percent to a decimal, divide by 100. So let's look at our first example. How long will it take an investment of $1,000 if it's invested at an annual rate of 12% compounded quarterly? So if we literally line up all our variables, we should be able to do everything. So right now, $1,000 is how much we have to invest. It's tripling, so the amount I want is $3,000. My rate is 12%, which I'm going to write as 0.12, and compounded quarterly is 4. And time is what we're trying to find. So if I literally plug into P1 plus RN to the NT, then it's 3,000, 1,000, and please remember it's raised to the 4x because you're compounding it 4 times in that year. So please be advised this is attached to your exponent. So your first move on these problems is always to divide this out so that we are solving for our exponent, which is attached to the parentheses. So at this point, we're going to take 3,000 and divide it by, which is obviously 3, and then you want to take 1 plus 0.12 and divide it by 4. You can put that right in a calculator, and you get 1.03. Please be careful. If you get something here that's very long in decimals, like 1.0006, please go all the way to a number, or in reality, you should round to 4 decimal places at a minimum whenever we use logs. So our next step is going to be that this is an exponent, that's a variable, which means in order to solve this, I have to use logs. So I'm going to log base both sides. So if I show every step, it's 0.3 to the 4x. And when I have an exponent, it becomes a coefficient. So log of this. And at this point, I just use division. I divide by the 1.03, and I get 4x equals log 3 divided by log 1.03. I get 37.1670, and I divide by 4, and my answer is 9.3 years. Okay. So that is definitely the harder of the interest problems. That's the problem in which requires logs because your exponent's missing. If we simply take a look at this, you have $100 invested at 7.2% interest compounded annually. So just make sure you understand N is 1, R is 0.072, because that's how you write it, and T is 10. P is 100, and now simply plug it in. So it's literally A equals 100, 1 plus 0.072 divided by 1 if you need to, raised to the 10 times 1. And you literally plug that in a calculator as is, and your $100 turns into $200.42. Before I forget, I know I'm backtracking. I just want to explain about tripling. You don't need to know your starting amount if I talk about tripling money. Just note that if you had $1 and it tripled, it would be $3. If you had 1,000 and it triples, it's 3,000. If you had X amount and it tripled to 3x, when you divide, it's always going to leave you a 3 here. So just note you don't have to have a starting amount if I make it a tripling problem or a doubling problem or even quadruple. All right, please try this one by yourself. Bank A is offering 6% compounded monthly. Bank B offers 6.1%, but it's compounded quarterly. Which bank would pay more each year? So please pause the video, try this. So in reality, they're only asking about the interest. The interest comes from how much it's offering divided by how much it's compounded. So 0.06 divided by 12 is 0.005, that's 0.5%, and 0.061 divided by 4 will give you 0.015, which is 1.5%. So your answer is bank B pays more interest. How many years will it take $1,000 to grow to $74.50 in an account that earns 12% interest compounded quarterly? So go ahead, you can fill in everything automatically. Your principal is 1,000. You want to turn it into $74.50. Your interest rate is 0.12, N is quarterly, 4, and T is missing. So extremely similar to the first problem, so please stop and try that by yourself. So hopefully you realize, please remember this is attached. Your first move is to divide by the 1,000. That's going to give you 7.45 equals 1.03 again to the 4x. I'm going to log this. I'm going to get 4x log 1.03. I'm going to divide by the log. Get 4x equals and divide by 4. 16.9998, 16.98 years, 17 would be fine, if, depending where I asked you to round. Just note that these logs, you should never result in a negative number because we're talking about time, and negative would make no sense. So just make sure if you happen to ever switch these on a wrong kind of problem, then you may end up in a negative. So that's where you want to kind of pay attention that you put them in the right spot, that you are gaining to 74.50, but you started with 1,000. The next type of compound interest formula we have is with exactly the same thing. A is the amount you invested, P is the principal, but now we have E. And E is a number that's 2.6 something. That is when you are compounding continuously. That means every day, whatever your value is that day, they're going to compound it again on top of that. So again, R is your interest rate and T is your time. So there's not too much more of a difference besides just making sure you use E, and E's on our calculator. So if you try this first one, you have 1,500, it's invested at 5.8, and it's compounded continuously. The way you'll know the difference in the problem is you will only use this formula with E when you see the word continuously. So for this problem, we're going to do 1,500 E, and you don't even have to use parentheses. I was just doing it. It's 15 times E, and then it's to the power of RT. So your interest rate's 0.58 and then 7. Just make sure you either do this first or when you put in a calculator, you put this in parentheses. So 1,500 times second, the natural log. That's where the E button is. Second, the NL, which is under log, natural log, and then 3.058 times 7, close, enter. It's 2251.20 cents. Okay. And if you'll do this one by yourself, it's exactly the same thing. So try that one. Took 500, that's my principal, E to the power of 0.08 and compounded for 15 years. So just multiply it out. Compounding continuously should make you more money because it's taking the interest you make every single day and compounding it on top of each other. So it moves faster. Okay, and now let's look at one that's going to require a log. So you want to triple your money. So again, it really doesn't matter what your value is if you can understand that. But in theory, if you wanted to see it, you would put 7550 here, E to the 0.0725 to the X, and you would equal whatever 75 times 3 is. So 227,550 times 3, 22650, but does not matter because your first move is going to be to divide, and 3 equals E to the 0.0725x. And since we're using E, you are going to natural log both sides. So x equals the natural log of E. And then you will know that the natural log of E is 1. That's what we already know. So you simply divide by 0.0725. My final answer is x equals the natural log of 3. You just put that in a calculator. Make sure you close the parenthesis, divided by 0.0725. 15.2 years. Okay. So that's our 2 types of problems. Here's your notes. I'm sure you can get through a few of these problems. If you have to work together, great. See ya.